friends, welcome to Veteach. Today we are going to discuss about very important concept in data structure, nothing but linked list. Yes, so far we have discussed about arrays, isn't it? In arrays, how the memory is allocated, okay, and what are the types of data structure. So data structure types. So we all know about arrays. So now let us learn about linked list. So what is a linked list? Let us know about linked list introduction. It is nothing like a linked list is a, we all know that it is a linear data structure according to representation, and according to memory allocation it is a non-linear data structure. Okay, so here how we represent the what is the use of linked list. So how it is going to represent? Yes, linked list is represented in type of node. So this is the node. Okay, in node we are having two members. This is the data member and this is the next member. Okay, so linked list means when we go for linked list, when we choose for linked list, actually when we go for arrays in order to store the elements in sequential order, isn't it? Actually we have seen stacks representation. We all know how the stacks will be represented, how the array, how the elements will be represented. We all know, isn't it? So let us know what is the use of linked list. Okay, here for example, if you give int array of size 5, so I am assigning the elements like 1, 2, 3. Okay, so what the memory allocation do? So the allocation will take part from 0 to 4. 0, 1, 2, 3 and 4, isn't it? So 1, 2, 3. So this is empty, this is empty. So 0 at the position, first position and second position. Whereas third and fourth positions are empty. Okay. Now I am giving two more elements like 3, 4 and 5. So 4 will be inserted and 5 will be also has been inserted. Okay, so I have inserted all the elements. Now I am going to insert one more element. Is array will store one more element? I am just trying to insert only one element beyond the size. Okay, will array allows that element? No, not at all. Why? Because we have set the fixed size of the array is 5. So it gives the only maximum size. It allows the maximum elements only 5 elements. So it doesn't allow one element also. Okay. So okay, you can see here the drawback. So it is somewhat fixed size. Okay. For example, in program implementation, while you are implementing the program by using array, you want to change the size while implementation, while execution. It happens? No. You don't know whenever you don't know the size, what we do? One thing we do, what we do? We go for maximum size allocation. For example, we go for maximum size allocation like A0 to 49. So when we go for maximum size, if we give largest size, so we can use how many elements, whatever you want. So just I am trying to use only 1 to 20 elements. So whatever the 30 elements position, the 30 elements will be 0. See what is happening here? We are unnecessarily wasting the memory, isn't it? So this is what about drawback in the arrays. So in order to eliminate the drawback in the arrays, we go for linked list. So linked list is like representation. When linked list is nothing but a dynamic memory allocation. You can store elements unlimited whenever you don't know the size of the array, and whenever you don't know the size, you can go for dynamic memory allocation and you can store the elements in the linked list. So this is the one of the advantages while using the linked list. Okay, how the linked list, what are the uses of linked list? Let us see what are the uses. Okay, the uses are, so as the list size is limited to the memory size, we doesn't need to declare in the advance. So there is no need to declare the size in advance. And here empty node cannot be presented in the linked list. Why? Because in array what happens? In array, if we doesn't give the elements, for example 1 has been given. If you declare a of 2, if you give the one element, what the remaining remaining memory will do? It stores a 0, isn't it? But here what we are doing, empty value has been stored in the array, but in the linked list it can't be present in the linked list. Which one? Empty node can't be present in the linked list. Okay, so we can store the values of like data types, like primitive data types in the single linked list. So these are the uses of the linked list. You can see here representation, like, see, in linked list representation generally how it represent means, so the representation done like in this way. This is the node. So the node is having the two parts. As I said, this is the data part, this is the link part. Okay, so this is the data part, this is the link part. What is this link contains? This link contains the next node address. This link contains the next node address. For example, if this node is stored at 100 location, if this node is stored at 150 location, if this node stored at 200 location. So in array what happens, guys? For example, if you take these three elements 12, 20, 28, okay, see, if this memory location is 100, what the 20 location will be? Obviously 102. Obviously 28 location will be 104, isn't it? So you can see here the memory locations are in sequential order. The elements are placed in sequentially, isn't it? Okay, here in linked list, so we are going to store the elements. So you can see 12, 20, 28 are sequential. So after 12 what element we have stored? 20. After 20 what elements we have stored? 28. This is the order. So same order we are going to represent in the linked list. See, the functionality should not change. Okay, whatever, wherever you want to store, you can store. But the order should not change. What the order? I have given 12, 20, 28. So this is the order should be maintained in the linked list also. Okay, so see, 12 has been created somewhere in the 100 location. You can see here. Let us assume 20 has located in the 150 location. 20 has located in the 200 location. Okay, in array what happened? As they are in the sequential order, we can access the elements in order, like by using the for loop, but these are not in order. That is one of the drawback. In linked list, the nodes are created dynamically. We don't know the memory locations will be created in order or non-order. We don't know. It doesn't matter. So what I am trying to say is, here the element should not misplace the order. See, if for example some more, I want to insert an element like 30. So in array I am inserting 30. So what will be the memory location? 106. Okay, so the order should be 12, 28, 30. In linked list, if I place the memory location like 30, if I am creating memory element like 30 in 102, for example 102. So according to memory allocations, you may get a doubt. So in here the memory allocations are not in sequential order. Here not in sequential order, but we can trace the nearby locations, like after 100, who is the nearby element? 102. After 102, who is the nearby location? 150. After 150, who is the nearby location? 200. You may get a doubt. By tracking the memory allocations, by tracking the nearby locations, you can trace the elements, right? But after 100 location, who is the one nearby location? 200, 102. So what will be the order? After 12, you may trace the element 30. Okay, after 102, who is the nearby location element? 20. After 150 location, who is the nearby location? 200. Means the element is 28. But you see the order, 12, 30, 20, 28. Is the order I have given? No. What the order I have given? 12, 20, 28, 30. 30 should comes and store it in the end of the list. Here what we are going to do, what is happening is, in linked list the memory allocation is done dynamically. We don't know whether the memory is allocated in order or non-order. We don't know. If you trace according to the memory allocations, you may misplace the principal. The principal might be get corrupted. Okay, so you should not consider according to the memory locations whatever they. But what we need to do is, first of all, whatever the element you created, the node should be created and store the element in the data field. The link field is so this is the link field where the next element address should be stored here. So that whenever you trace the 12 element, whenever the next element address is stored here, then you can go, then the link will be created to the 150 location. Then you go for 20. So you can go for 150 location. Which element is there? 20 element is there. So you access the 20 element. Action means picking that element. So after 20, which element have been created? 28. What is the memory location? 200. So store the 200 location in the 20 next element. I mean 20 link part, in the 20 link part. So that the link will be created to the 200 location. Okay. So after accessing 20, so where it goes? It goes for 200 location and it accesses the 28 element. Okay. So what is the next part? What is the link part in the 28? Null. It means that there are no more elements. See, the order has not been misplaced. The order whatever have given, same order elements have been accessed here. How have been accessed those elements? By storing the next element address. After the 20, who is the element here? After 12, who is the element? Next element 20. By placing the 20 address in the link part. After 20 element, after the, what is the next element of 20? The 28. By storing the 28 element in the link, in its link part, so that you can access the order. So in this way you can access the elements in order. This is how we linked list is represented. Okay. So these are the uses of linked list. Let us meet in the next session with a new topic. Thank you.